Good morning everyone. Today's our topic is osmosis. So I will explain you what is osmosis. Actually it is the movement of water molecule from low concentration to high concentration of solution. I not told to from low concentration of solvent. I told low concentration of solution to high concentration of solution. Okay. And what we need semi permeable membrane. Why? Because it will allow only the solvent molecule to pass through it, but it will not allow solute particles to pass through it. Is it clear? So it is written here also, semi permeable membranes only allow the small molecules but not allow the bigger solute molecules. That's why in osmosis movement of water take place, not the solute. So I will explain you with the help of diagram. You can see here. You can see here I have taken the solution on right side and solvent on left side. So itself what take place? Water movement from A to B. So after some time you will see here more water present here on B side as compared to A side. And what we have taken here, this is the semi-permeable membrane. So you can say here now, if water movement take place from low concentration to high concentration, then it is called osmosis. So our next topic, it is osmotic pressure. So actually what is osmotic pressure? In this we have to prevent the osmosis. So how you can prevent the osmosis? By applying some excess pressure. Okay, if you will apply the excess pressure, then you can prevent the movement of water. Okay, so where you have to apply? You have to apply on the solution, so that there is no movement of solvent molecules through a semi permeable membrane. This is called osmotic pressure. Okay, so expression also given here for the osmotic pressure. It is represented by pi, that is equal to CRT. So what is C here? It is the molarity. Okay, in terms of molarity we have taken here R, it is the constant, and T is the temperature. Okay, so before doing this, first I will explain you with the help of diagram what is osmotic pressure. So you can see here I have taken the pure solvent and there I have taken the solution. Okay, so by itself what take place? Water move from A side, this left side, to right side. Okay, but if you want to prevent this movement, you have to apply the pressure on solution. Okay, so that there is no movement of pure water, okay, into the solution. This is called osmotic pressure. So you can see here, you can say here na, in osmosis movement of water take place. In osmotic pressure we are preventing the movement of water, okay, by applying the some pressure, okay, on solution. So now you can see pi is equal to CRT. So we can solve the molar mass also with the help of this expression. As you know, what is molarity? It is the moles of the solute divided by volume. Okay, moles of the solute divided by volume. So if you will open the moles, then what you will get? Given mass by molar mass. Is it clear? Given mass by molar mass. So by using this, you can calculate the molar mass of the solute. Okay, so pi is equal to molarity into RT. Okay, by rearranging we can get the molar mass. So now there are three types of solution: isotonic solution, hypotonic and hypertonic solution. What is the meaning of isotonic? Here the word given iso. Iso means same. Hypo means less. Hyper means more. Okay, so it is very important in board exam also coming this iso, hypo, hyper. What type of movement take place here and from where to where? Okay. So you can see with the help of diagram, in isotonic we have taken here the RBC cell. Okay, in isotonics what we have to keep here, outside and inside the RBC, whatever concentration is there, it should be same as that of outside. Okay, so we have to make the solution in that way so that the concentration will be the same on both sides, so that it can have the same osmotic pressure. Okay, if we will ask that from where water will move, then you will say there is no net movement of water, because in both direction equally the water movement will take place. But in hypotonic solution, hypo means less, then outside what you have to keep, less concentration. Okay, in hypertonic you have to keep outside more concentration. Okay, so more concentration, we are talking about the solution, we are not talking about the solvent. Okay, so more concentration of solution you have taken, it means outside less water present. Okay, if it is less water present, then inside more water present. Then where will be the flow of water will take place, from in to outside. Is it clear? So opposite case it is present in hypotonic solution. In hypotonic solution, outside less concentration of solution is there. Okay, then inside more concentration present of solution. So what you will say, where water is present in more quantity, outside. Okay, so water will move from out to in. So you can say finally, in hypertonic solutions shrinkage will take place, but in hypotonic solution swelling will take place. Okay, and then collapsing will be there. So actually 1 marks question they are asking, the what is the net moment of water in hypertonic solution, you will say from in to out, inside to outside. In hypotonic, from outside to inside. In isotonic, there is no net flow of water, in both direction equally it will move. Okay. So now you can see here the definition. Isotonic solution are two liquids that have the same osmotic pressure at the same temperature. In hypotonic, in comparison to a more concentrated solution, solution with lower concentration or low osmotic pressure is termed as hypotonic. Okay, hypo means less. If it has low osmotic pressure, means where it should be, outside. In hypertonic dilute solution, you have to take a solution with high concentration or osmotic pressure. It is called hypertonic. Okay, it means you have to keep the outside high concentration of the solution. Okay, so next term it is coming here. Now it is reverse osmosis. Three terms are there: osmosis, osmotic pressure, and third term it is reverse osmosis. As according to the name, it is suggesting that in osmosis water will move from pure to solution itself. In osmotic pressure we have to prevent the osmosis, but in reverse osmosis you have to allow the movement of water from solution to solvent, from solution to solvent. Okay, so where we have to apply the more pressure in case of reverse osmosis, because we are forcefully allow the movement of water from solution to solvent. Okay, so it means we can say now, in osmosis there is no need of pressure. In osmotic pressure we need some excess pressure, but in reverse osmosis we need even more than osmotic pressure. Okay, so what is reverse osmosis? The solvent will flow from the solution, forcefully we have to allow, into the pure solvent through a semi-permeable membrane. If pressure greater than osmotic pressure is applied, if you will apply more than osmotic pressure, then only it will move from solution to solvent. Is it clear? This is called reverse osmosis. Okay, so where we are applying this concept, desalination of seawater. Okay, so that we can get the distilled water, or you can say we can get the pure water. So you can remove by using this process salt from the water. Okay, So you can see here the diagram. Here solution we have taken, there pure solvent it is present. If you will apply little excess pressure, it will not allow the movement of water from left to right. But if you will apply even more than osmotic pressure, even more than osmotic pressure, then it will allow the movement of water molecule from solution to the solvent. This is called reverse osmosis. Okay. So our next topic, it is abnormal molar mass. Actually, what is this? The molecular mass of substance is said to be aberrant molar mass when it is determined by investigating any of the colligative properties that differ from theoretically expected value. So what are the colligative properties? Actually, you have done many terms in previous topic. For example, elevation in boiling point, depression in freezing point, osmotic pressure. First, you have to tell to me that in every cases we have used the moles of solute. Definitely we have used. Okay, so wherever moles of solute will come, all are the colligative properties. Okay, so we can say now what are the colligative properties which depends upon the moles of solute. Okay, so that involves colligative property. So here few terms are written here. Aberrant molar mass, which is determined by investigating any of the colligative property that differ from theoretically expected value. Theoretically means what we are thinking, means actually what they have. Okay, but if we will calculate the molar mass experimentally, then it will comes out to be different from the theoretically expected value. For example, I will take the example, suppose NaCl. Actual molar mass of this compound, it is 23 plus 35.5. Okay, after addition 58.5 we will get. It is the actual molar mass. But if we will calculate by experimentally, then we will get the different values. So how it has occurred. So this process involved in that, this is called abnormal molar mass. So something has taken place here, that's why the molar mass it has changed. Okay, so you can see here abnormal molar mass are observed when the solute in the solution forms connection, means association. If some particles associated, okay, when the solute in the solution undergoes dissociation, or maybe some dissociation has taken place. So this is called abnormal molar mass. Okay, so one example I am giving to you. Suppose you have taken the example of benzene. Initially we have taken the 1 moles, but in solution it has associated and made the dimerization. Okay, they undergoes dimerization. Benzene will dimerized. Okay, so experimentally what we have got, the double amount of benzene. Okay, the molar mass it has changed. First it was according to 1 mole, but now it undergoes association and giving the more weight. So we can say we have got the abnormal molar mass. Okay, in the same like this we can say about the dissociation also. For example, we have taken NaCl. Initially we have taken 1 moles of NaCl, but in solution it has dissociated into the ions, 2 ions, sodium ions and chloride ion. So you can see here how many moles of sodium ions we have got, 1, and chlorine 1. Total it is equal to 2. So experimentally what we have got, different value after dissociation as well as after association. Okay. So this gives the abnormal molar mass. Okay. So one terms we are having, this is called Van Hoff factor, that is represented by I. And this Van Hoff factor, it is very important. Every times in board exam it is coming in any form. Okay. So actually how you can represent for association and dissociation, I is equal to normal molar mass divided by abnormal molar mass. Okay, what was the theoretically value? It is normal, but what experimentally we have got, it is called abnormal molar mass. So we can say in terms of colligative property also, observed colligative property divided by calculated. So calculated it is the corrected one, observed it is after experiment. Okay. So in other forms, in association, how you can tell total number of moles of particles after association divided by number of particles before association. It means what we have taken, that you have to keep down, and after association what you have got, you have to keep upside. So you can see here, in association number of particles will always decreases because of connection. Weight will increase but numbers will decrease. It means colligative property will decrease but molar mass will increase. Suppose you have taken A, but after association it will become A2. Okay, number it will decrease. Okay, but molar weight will increase. Clear? Suppose you have taken the 2 moles, 2 moles you have taken, and it will dimerize and it will give the A2. The molar mass will increase because it has made a bond between the 2 molecules. Okay. So formula how we can represent, initially you have taken the 1, finally what you have got, 1 minus alpha plus alpha by n. Suppose A, it will give A n. Initially what you have taken, it is the 1. Okay, initially at that time there is no moles of an, but after some time it will become 1 minus alpha, then it will become alpha by n. Okay, after some time. So total number of moles present in that solution, it is equal to 1 minus alpha plus alpha by n. So Van Hoff factor, it is represented by 1 minus alpha plus alpha by n divided by how much quantity you have taken. Okay, so how much quantity we have taken? 1. So no need to write. It means Van Hoff factor will becomes equal to 1 minus alpha plus alpha by n. Similarly, we can explain dissociation. Suppose you have taken an, but after dissociation it will become Na. Number of quantity will increase. Initially you have taken 1, at that time it was not present, but after some time it will be 1 minus alpha. Alpha has dissociated, and how many molecules formed? N alpha. Okay, so in that solution how much quantity present? Total it is 1 minus alpha plus n alpha. So I can be calculated by how much quantity present that time and divided by total amounts we have taken. That we have taken 1, no need to write. So finally the formula becomes I is equal to 1 minus alpha plus n alpha. Okay, so very important formula it is. How you can solve for association? I is equal to 1 minus alpha plus alpha by n, and for dissociation I is equal to 1 minus alpha plus n alpha. Okay, so what is n here? It is the number of ions formed, And what is alpha? It is the degree of dissociation. So one example I will give you. If dimerization will take place, then in case of association formula, you have to keep the value of N, it is 2. Okay, in association, if dimerization take place. If dissociation take place, okay, number of ions formed, it is 3 in dissociation. Then you have to use the formula of dissociation. Then the value of N, it will be 3 into alpha. Okay, so few example you can see. Suppose you have taken Al2O3, then how many ions will be formed? 2 ions of aluminium and 3 ions of oxygen. Then N value you can keep here, total 6. Clear? Suppose it is barium nitrate, then N value it will be total 3. Okay, how many ions are formed here of barium? 1, and nitrate it is 2. Okay, so it is very important formula for association and dissociation. Again I will write here, I is equal to 1 minus alpha plus alpha by N for association. I is equal to 1 minus alpha plus N alpha for dissociation. Okay, so we will complete our this lecture up to this only. So do this. Okay, thank you and have a nice day.